First, we click on the Add New Vessel button. Here we can fill in important information about the vessel, like its name, report number, service, project number and software operator. Filling in as much as we can of this information is very important, as it will allow us to easily search for our vessel in the database later. We can select vessel type, pressure vessel or heat exchanger. We can select vessel orientation, horizontal or vertical. Selecting vertical orientation will allow for designing spherical pressure vessels too. Here we can select the vessel design code. And here we can select whether to enable the shop or site hydrostatic tests and fill in their data accordingly. Our next step is to create the vessel's process cards by clicking on the Process Data tab. Here we click on the Add New Process Data button to create a process card. Here we can fill in the process card's data. In vClavis, user inputs the total corrosion allowance, which the software will always consider as internal corrosion allowance, being on the safe side. We will make a vertical vessel in this example. We select a cylindrical shell as our first component. In the Component Description tab, we will need to input the component name. Choose a simple name. For example, for the first shell course of a vessel, enter S1. Additional info may be input on the Component Description cell. On the right, we see some calculation options that only apply to the design code ASME. Next up, we move right to the Component Attachment tab. Here, since we are making the main shell, there is no attachment location available, apart from axis starting point 000, as shown in the component location and attachment icon on the right blue dot. Next, we move to the Design Data tab. In the Process Cards Input chapter, we can select whether we want to verify the component for internal and external pressure or internal pressure only. If multiple process cards are used, i.e. multi-chamber vessels, user may select applicable card. In the Shell Data Input chapter, we can select different options like the way the cylindrical shell is formed, fabrication data, or how to input geometrical data based on shell inside or outside diameter. While creating the component prior to input all data, ignore any red or orange warning pop-ups. We can also change the weld efficiency factor. Next, we move on to the Shell Geometry Input chapter. All input geometry data are self-explanatory. For more complicated components, relevant sketches can prove useful. We can click on the arrow button to modify the modulus of elasticity necessary in external pressure calculations. Here we can select any available elasticity value from various tables. The table selection can be changed via the Select Table drop-down. Now we need to fill in the unsupported length of shell. By clicking on the right info button, we can view calculated unsupported shell length for simple pressure vessels. Assuming we have two elliptical heads, according to the info box, our unsupported length value is 2,246 mm, and considering a straight flange of 50 mm for each head, our total unsupported length comes out at 2,347 mm, rounded up. Important code aspects are provided on the left info box regarding the consideration of unsupported shell length. Next, we move on to the shell material data input chapter. Upon a vessel's first component creation, software uses default materials. We may change material by clicking the Add Material button. Replace or Edit Material option can only be used after the component has been calculated at least once. Here we can click on the Advanced button to search the database for a material based on certain criteria. For now, we will just select a different material to add from the initial list. Having entered all geometry details and having selected materials, we must run and save the component by clicking on the Calculations Details tab. Until that tab is clicked, none of our input will be saved to the database. If component creation is terminated prior to saving, by clicking the red X button, we would have to repeat the procedure from the beginning. This is the calculation results screen, where we can view the results of component calculations separated into different chapters. There are red and orange warning markings and chapters. Red means calculations fail, while orange indicates warnings of minor importance. Let's try to replace the material with another one. We use the Advanced button to search for a material with a specific spec number. Note that when replacing or adding a material, we must always confirm our choice on the bottom right of the material window. Again, we run the component so that our change of material is reflected in the calculations. And now we see that no errors or warnings were produced. In the Component Checks panel, we can view some important calculated results, i.e. required shell thickness, in real time. When modifying any of our output, the component checks and component warnings will be re-evaluated automatically, as shown below. A failed component check will be marked with a red X mark, while a successful one with a green check mark. In the Component Liquid Input chapter, user may specify the liquid level on the current component. We simply select the Full button to fill it with liquid and the Use button to confirm. We can see that the component checks have been updated accordingly. And of course, we click on Calculation Details to save our changes. We can exit the component creation screen by clicking on the red X button. And we are back to the vessel desktop view. Our first component has been created successfully.